Hi, I'm Libby Heaney. I'm a visual artist with a background in quantum computing and quantum physics. I'm based in London. I use this sort of background in science and technology in my art practice. So I typically work with new tools such as machine learning, quantum computing now, and virtual reality and games engine stuff, immersive environments. Yeah, so I'm really interested in the power structures around new technologies, who they empower and who they disempower. Things like prejudicial biases and thinking about really the ethics of these really powerful tools that humanity are developing. And then as a counter to this, I'm really interested in kind of deconstructing these hierarchies in quite a playful way, often referencing kind of surrealism or Dada, putting in noise, nonsense, queering these systems or rewilding these systems to create new alternative realities that are perhaps more equal and value the collective over the individual. So in the last 3 years, I've really been working with a bit of machine learning, but mostly developing work using quantum computing. So I think I was one of the first or the first artist to do this back in 2019. And I've been working with IBM's quantum computers. Obviously, I don't have a quantum computer of my own, so I'm always negotiating access, using kind of my connections in the field to get access to these machines. And I've been developing a new aesthetic based on the sort of entanglements within quantum computers and using this to sort of manipulate images to make them plural, to entangle them to each other, to deconstruct forms in images, questioning notions of truth and subjectivity even further than has been questioned already in art history. The way I'm working with quantum computing, my expertise is in quantum entanglement. Most of the papers that I published were on this phenomena, exploring its foundations, exploring its applications, how you can use quantum entanglement to communicate in different ways and to process information in different ways. And now with quantum computers, I'm using data from quantum entanglement. There's loads of different entanglements that you can create inside a quantum computer, and they all have different sort of architectures, let's say, and I'm tracing those contours and bringing those to life. It's impossible to represent entanglement because it exists in a higher dimensional space. But what I can do is trace contours of this space and use that to manipulate and animate images and 3D models in ways that would not be possible without quantum entanglement. So in some sense, I'm allowing audiences to sort of see and experience the invisible processes inside a quantum computer. But I'm not trying to be didactic generally in my artwork. I think it's more, what I've been working on so far is more sensory, perception-based, emotional experience where people can feel destabilized by these structures. I've been putting them into these immersive installations, and that's one of the things that will be coming to art by. And then also I use entanglement as a metaphor conceptually for exploring relations between things, between people, between entities in our world in a non-hierarchical, really strongly interconnected sense, where if you try to retrieve an individual from these entangled systems, you actually destroy them. That's how it works within quantum computing. So imagine if we could transport that logic to our everyday, where we think of ourselves as connected to the environment in much more strong ways, or to each other. So there's this new sense of collectivity. And I think, I've started exploring this, and this is definitely something that over the next few years I'll be bringing out in my work thematically even more. Hi, so this is my desktop. I'm currently on my laptop, but this tends to be the computer I work most on. Yeah, it's quite tidy. I'm quite pleased with that. And I guess what you see initially is this image in my background, which I'll talk about in a second. I don't know why I've chosen it as my background, but it's a really good starting point for how I've been using quantum computers to manipulate images. And within all the different icons you can see here on my desktop, you get a sense of some of the apps that I use, like Blender and ZBrush and Adobe and Topaz. Security is also important to me as I work with tech. So I understand the pitfalls. So you've got NordVPN and Tor, and then Unity. So you can and then there's some images that I usually have on my desktop because I'm using them as reference images. Various things that I use quite often. So going back to this image in the center. So this is actually from 2019. It was one of my first experiments using quantum computing in art. So I wasn't thinking, oh, I'm making an artwork like for an exhibition at this point. I was experimenting with quantum computing. I didn't know what aesthetics I could create. So to begin with, I started painting on really, really wet paper an image of a squid. And I chose a squid because it's an alternative intelligence in the universe. It's very intelligent, but not in the same way as humans. And I chose to paint on really wet paper because the blurring of forms really reminded me of quantum entanglement. It's very different. It's not the same thing, but it has sort of resonances with it. And you can even see when I took the photo of this painting, there's still a pool of water on it. So it's kind of reflecting some of the environment back. And then I sort of collaged this with a background, some sky. And then that was kind of my source material for working with quantum computing. And then obviously a digital image is made up of RGB values for each pixel. And that's really what I'm manipulating using data from quantum entanglement. And you can see so these subsequent frames, this middle image and this right-hand image, these were generated not by necessarily me deciding the choices, like they're generative. I didn't decide how they would look. They are made by looking at entanglement in different ways and then using that data to alter the image in a sort of with an algorithm. And you can see you get this sort of pixelated, blurred aesthetic where the image kind of becomes inverted. You recognize the forms from the first image here, but the colors have changed. You've almost like started to turn the image inside out. And you can see the video that I made from this. So what you're watching here is each frame in this animation is generated using quantum entanglement after the first frame. So only the first frame I made, but I'm looking at the quantum entanglement slightly different for each frame. And then you get this sort of, the image almost becomes fluid, but in a pixelated fashion. And this reminds me of a phenomena from quantum physics called wave-particle duality, where particles can behave like waves and typical wave-like phenomena like light behave like particles. Depending on how you look at these entities, they act in different ways. So there's no ultimate truth to reality. And what I'm showing with this image, this animation, is there's almost no absolute way of once this image is encoded with quantum entanglement, there's no absolute way of seeing it. The image starts to slosh around in the pictorial frame. All the information of this image is currently in this representation, but it's kind of moved into different configurations, and then you can see it gradually comes back again. So I didn't control this process. This was generated from the quantum computer, from the quantum entanglement. So for me, it's natural to work with time-based animations because then you really get to show the sort of fluid nature of quantum physics. Yeah. This is when I was, again, a study, but I was entangling two images here rather than working just with one. And this is right in the middle where two images are very entangled. And this is the Earth and an octopus. And you can kind of see traces perhaps of the octopus legs, but you've got something that's greater than the sum of the parts. So when I entangle two images together, I'm working with IBM's quantum computers and their software, Qiskit software, which is essentially a Python library. So I'm working in Python, but when you're programming a quantum computer, you're using Qiskit. So I'm working at the level of assembly, quantum assembly code, so the zeros and ones, because that's what I'm trained to do. Yeah, at the moment, as far as I know, there's no Photoshop for quantum, although I'm sure there will be at some point, but maybe in like 5, 10 years. Yeah, so I'm quite privileged in the sense that I know how to do these things myself. I think if you're not trained in quantum computing, you'd have to collaborate with scientists in order to get these aesthetics or to develop other. There must be like an infinite number of aesthetics that you can develop using quantum computers, just because of how quantum computers work. So this is some quantum. I've called it glitches with alpha, but I'm using this throughout the Arbite exhibition. It's using the same code as but I showed you from the initial work that was on my desktop, the background of my desktop. But I've added an alpha channel, a transparency channel, and it's really short sort of glitches. But this is generated using the same code, and applied to one of my paintings as well. But I'm keeping just the abstract section of it, and this is featured as a motif throughout the Arbeit exhibition. You might be wondering what quantum computers look like. One of the videos I've made for the Arbeit exhibition has 3D models of how current quantum computers look. And you can see these glitches are appearing in the background sometimes here. Something's not quite right with these videos. There's some quantum entanglement coming out to get the audience members. And in these videos, I'm really using the language that quantum computing companies like IBM, like Google, but a myriad of startups as well, are using to sell their tools and bringing audiences into kind of what quantum computers will eventually be used for when they're fully developed, because they've only got sort of prototype quantum computers at the moment. But you can see in the background all of these 3D renders that I've made of, different companies' quantum computing tools, these gold chandeliers. They look really strange compared to digital computers, because most quantum computers need to be cooled down close to absolute zero, which is minus 273 centigrade. So really, really cold. That's colder than deep outer space. They almost look like these deep sea diving tanks. And that's because at the top they're quite warm. And then each layer as you go down may become colder and colder. And then the quantum chip sits at the bottom of a gold-like structure like this. You don't really see it because they're so small compared to the rest of the structure. Another piece that will come to Arbeit is Ent, which is just being exhibited at Sharing-Stiftung in Berlin with Light Art Space, who commissioned it. And Ent brings these quantum experiments that I've been showing you into an immersive environment, really to allow audiences to experience the invisible processes within quantum computing using their bodies, because you're really like destabilized or swept up with these graphics, and to allow people to think about or feel these things, as opposed to kind of providing them with a didactic, more narrative-based experience. In English, the word ent starts words like entanglement, enter the black box, enter on the keyboard, which is also return. And I'm inviting audiences to finish this word. And then the world is, this immersive world is inspired in part by Hieronymus Bosch's central panel from the Garden of Earthly Delights. So you can see here some of the architectural forms that are in Bosch. We've got these glitches in the sky, which are hybrid creatures that have been made plural and kind of extending across space like entanglement. And then we've got a sequence of hybrid creatures that the audience encounter. You'll notice there's no naked people in this. Actually, what happens is, unlike Bosch, which is all about carnal pleasure and desire and critiquing that or celebrating that, depending on your perspective, here the audience members become those people. And instead of being naked, what they're doing is their desires for new technologies are present. They're filming these immersive experiences and they're entangling to each other through technology rather than through touch and sensual pleasures. So in some sense, this work really critiques quantum computers. It shows positive moments of collectiveness through these utopic scenes where the forms really deconstruct and spread around the room in a very sort of pleasurable experience. So these squares were all generated using data from quantum computing, but when I started to work in 3D, they sort of destabilize you, or you feel entangled to them as they spread around you. And then on the other hand, the work randomly collapses at different points. So the colors desaturate, and all the forms that were previously ebbing and flowing and reconfiguring following quantum rules, they collapse and the world becomes dark and the bass rumbles. And we realize that there's different possibilities situated somewhere between heaven and hell that the future of quantum computing could lead us to. The work Ent that I just showed you and the other video with the quantum computers are coming to Arbeit for my solo show there, The Evolution of Ent. QX. So QX is a fictional company that I've created for the exhibition to allow me to kind of talk from the corporate perspective about quantum computing. As you saw in that video, there was lots of text that I'd lifted from various tech companies. First of all, some audiences might not even know much about quantum computing, so I hope they start to understand kind of the potentials of it, both positive and negative. For Arbeit, I'm really positioning ENT, the immersive experience, as a tool that a tech company might use to sell quantum computing. So I'm kind of adding another layer of criticality around my work, just for Arbeit. In the future, I think ENT will probably be exhibited in different ways. But I'm working with immersive experiences, and they can be quite commercial. At least myself, I often have adverts for immersive, Van Gogh or something popping up on my Instagram feed, and they're generally made for kind of spectacle and entertainment as opposed to this sort of critical, perhaps more critical art perspectives. So I'm just being reflective on what I've done. Audiences will get to take their own opinion, obviously, because I like to keep meanings in my work quite open, because that fits really nicely with quantum. I don't want to be too didactic. I have a bunch of quantum computing scientists coming maybe to the opening or other points throughout the exhibition, and they will probably be like, this is great. We will definitely be making immersive experiences as part of our company in the future. So different people, depending on your positioning, will see it as like more dark or more positive. I'm so excited for audiences to experience the immersive experience and then to come out the other side, and then there's a treat. I hope it's a treat for them. I'm really bringing the materiality back into the experience. So far it's quite screen based, and then I've started to build an installation and other objects that I don't want to say too much about right now, to really kind of bring people within to this world, but in a different way.